Hello, students. Today, we're going to build a very strong foundation on an extremely important topic in organic chemistry, and that is the nomenclature and structure of the carbonyl group.
So, to begin, let's start with a simple question from our daily lives. I'm sure many of you have seen nail polish remover, right? The main component in that is acetone. Have you ever wondered why acetone is such an effective solvent? How does it dissolve that tough nail polish so easily?
Well, the secret to acetone's power, and really the central idea of this entire chapter, is something called the carbonyl group. It is the heart of aldehydes, ketones, and carboxylic acids. And I'll tell you what, if you understand this one group properly, all these other topics will become so much easier for you.
So, what is this carbonyl group? At the simplest level, it is just a carbon atom that is double bonded to an oxygen atom. C equals O. That's it. So simple, no? But you should not let this simplicity fool you. This small structure is actually one of the most powerful and important functional groups in all of organic chemistry. Now, this is where it gets really interesting. Let's look at what happens to the electrons in that double bond. I want you to imagine the oxygen atom pulling the shared electrons closer to itself. It's like a little tug of war for those electrons happening between carbon and oxygen. And as you know, oxygen is more electronegative. What does that mean? It just means it's stronger. It has a much greater ability to pull electrons towards itself. So in this tug of war, who is going to win? Oxygen, of course. So because the more electronegative oxygen pulls that electron density away from carbon, a permanent separation of charge is created. We call this a dipole. This creates two poles. The oxygen atom, now having more electron density, becomes slightly negative. We represent this with a delta minus symbol, delta minus. And what about the carbon? Since it has lost some of its electron share, it becomes slightly positive, which we show with a delta plus, delta plus. Please remember this. This polarity is the absolute key to understanding all its reactions.
Okay, to make this concept of polarity very, very clear and easy for you to remember, let's use an analogy. Let's think of the carbonyl group as a small magnet.
You see, a magnet has a positive north pole and a negative south pole. The carbonyl group is just like that. It has a slightly positive carbon atom, which is like our positive north pole, and it has a slightly negative oxygen atom, which is like our negative south pole. And what is the first rule of magnets? Opposite poles attract. So that positive carbon atom will attract any species that is rich in electrons. And in chemistry, what do we call these electron-rich species? We call them nucleophiles. And this is precisely why understanding the structure became so important. You know, for chemists, realizing that the COO double bond had this polarity and reactivity, it was like finding a master key. Suddenly they could understand and predict the behavior of thousands of natural and synthetic compounds. It was a huge breakthrough. All right, so now that we understand the core group, let's picture the actual structure. Let's see how this builds into aldehydes and ketones. So in an aldehyde, the carbonyl carbon is always at the end of a chain. This is the main point to remember. It's at a terminal position. This means that the carbonyl carbon must be bonded to at least one hydrogen atom. Now, what about a ketone? In a ketone, the situation is different. The carbonyl carbon is within the chain. It is never at the end. It's bonded to two other carbon groups. You can think of it as being sandwiched in the middle. Acetone, our nail polish remover example, is a perfect ketone. The COO group is right in the middle between two carbon groups. Now here is a very, very common point of confusion for students, so please listen carefully. It is very important not to confuse the carbonyl group, which is C double bond with O, with the carboxyl group, which is COOH. They sound similar, but they are different. Remember, C double bond with O is the carbonyl found in aldehydes and ketones. But when that same carbon has a C double bond and an OH group attached, that whole COOH unit is a carboxyl group, and that is what we find in carboxylic acids. They are different functional groups.
Okay, so now let's talk about real-world reactivity. To really understand why this carbonyl structure is so important, let's compare it to another double bond that you are very familiar with, the C double bond in alkenes.
So you might think, okay, a double bond is a double bond. So maybe a C-double-O bond reacts just like a C-double-C bond. But actually, no. Their reactivity is completely opposite. And why is that? It all comes back to polarity. The carbonyl double bond, C-double-O, is polar. That slightly positive carbon attracts electron-rich species, the nucleophiles. But the alkene double bond, C-double-C, is nonpolar because the electrons are shared equally. So it acts as an attacker itself, and it attacks electron-poor species, the electrophiles. This is why their reaction types are different. Carbonyls undergo nucleophilic addition, whereas alkenes undergo electrophilic addition. It's fascinating, isn't it? The same type of bond, but their behavior is poles apart, all because of that one oxygen atom.
Okay, so let's do a quick recap. What are the key takeaways for your exam? First, the carbonyl group is a polar C=O double bond. Simple. Second, because it's polar, the carbon is slightly positive, delta plus, and the oxygen is slightly negative, delta minus. Third, this polarity makes it act like a magnet. That positive carbon attracts electron-rich attackers, which we call nucleophiles. And finally, this entire story explains why acetone, which is a ketone, is such a powerful solvent for other polar substances. See, it all connects back.
So my final advice for you, if you just remember the core idea of polarity, the magnet analogy, and the acetone example, I promise you this topic will feel much lighter in the exam. You will find it much easier to answer the questions. So keep studying hard, and I will see you in the next session.